Lisa.
Hi, Ariana.
What do you have there?
I got this milk, but I don't know if it's still fresh or not.
It looks dented though.
Yeah. Do you know how to check the freshness of the milk?
I think I know. We can use a volumetric analysis by doing a titration. You want to know how it works?
Yes. Let's go.
What is volumetric analysis? Volumetric analysis is a quantitative laboratory technique used to determine the unknown concentration of a specific substance analyzed. It works by measuring the exact volume of a reacting solution of known concentration, which is the titrate, that is required to fully complete a chemical reaction. The process is carried out through titration, which is classified into 4 different categories: acid-base titration, redox titration, precipitate titration, and complementometric titration. The titration process is titration, which is the important key of the process aside of titrate and analyze. Volumetric analysis in testing milk quality. Volumetric analysis, specifically titration, is a fundamental chemical method used to evaluate milk quality by measuring concentrations of specific compounds like acids, proteins, and adulterants. It helps detect spoilage, estimate nutritional value, and also identify illegal watering or the addition of neutralizers. The most common volumetric tests used in dairy analysis include acidity and freshness testing, detection of added neutralizer, protein determination, formaldehyde titration, and also detecting adulterants, which is chlorides and salt. In this video, we will talk about the quality in milk, which is acidity and freshness. Fresh milk is naturally slightly acidic, but elevated acidity indicates microbial spoilage, which is lactic acid fermentation. The method used is titrable acidity. A known volume of milk, usually 10 ml, is titrated with a standardized alkaline solution like 0.1 and sodium hydroxide NaOH or Dornic solution using phenolphthalein as a color indicator. Endpoint titration continues until a faint pink color persists for 10 to 20 seconds. The calculation is the percentage of the lactic acid is determined using the volume of NaOH consumed. The calculation will be lactic acid percentage equal to volume of NaOH in ml times normality of NaOH times 0.009 over volume of meat samples ml and overall 10 times it with 100. Normal range of fresh bovine milk typically reaches between 0.13% and 0.17% lactic acid. Higher percentages indicate souring.
Next, I will demonstrate the theory of volumetric analysis. As you all may know earlier, volumetric analysis is a quantitative chemical technique used to determine the unknown concentration of a substance by measuring the volume of a standard reagent required to react with it. That is why we will going to use acid-base titration. Acid-base titration is one of the volumetric analysis techniques where an acid or base is gradually added to a solution until the reaction reaches its endpoint, which indicated by a color change. Furthermore, I will tell you the reasons why acid-base titration is used in testing milk freshness. First, this titration is one of the techniques in volumetric analysis that is primarily used to measure the titratable acidity. Next, when the milk spoils, bacteria in it will ferment lactose into lactic acid, causing the acidity of the milk to rise. Consequently, this titration can accurately determine the precise volume of a base needed to neutralize the acid. This time, I will tell you the reaction of acid-base titration that we use in testing milk freshness. The purpose of this reaction is to determine the amount volume of a base needed to neutralize the acid. In this case, the acid in this reaction is lactic acid, which acts as the analyte, while the base is sodium hydroxide that acts as the titrant. The reaction in this test is lactic acid react with sodium hydroxide, which result to sodium lactate and hydrogen. To add on, the phenolphthalein indicator was used, and the endpoint of this reaction is from white color to light pink color change that indicated the acid already neutralized.
Materials that we need for this titration method are distilled water, 2 milk sample which is fresh and raw, sodium hydroxide solution 0.1 mole, and also phenolphthalein indicator. For the apparatus, we need retort stand, conical flask 250 ml, burette, and also pipette 10 ml. Now we're moving on for the methodology part. For the first step, we need to clean and dry the titration equipment like burette, conical flask, and also pipette. Then we need to rinse the burette with sodium hydroxide solution and fill the burette with sodium hydroxide solution and record the initial burette reading. So for the first step, we need to pipette 10 ml of fresh milk sample into the conical flask and pipette 10 ml of distilled water into the conical flask. We need to dilute the milk because dilution can break the thick milk emulsion, and also it helps to see the color changes easily. Then, moving on, we need to add 3 to 4 phenolphthalein into the conical flask as the indicator and swirl the conical flask really gently to mix it well. Then, we need to titrate the fresh milk sample inside the conical flask with sodium hydroxide in the burette slowly and shake the conical flask until it changed to pink color. For the seventh step, we need to record the end titration reading, then repeat the titration 2 to 3 times until we obtain two accurate readings within 0.1 milliliter of each other. Then we need to do the calculation based on the formulas that are given. After that, we need to repeat step 4 until step 9 but change the raw milk sample. And then we need to repeat the step 4 until step 9 but change the fresh milk sample with raw milk sample.
Moving on the quantitative analysis to calculate the exact percentage of lactic acid in our milk samples, we utilize the core titration formula shown on the screen. The molecular weight of lactic acid is 19.08 gram per mole, and we use a fixed sample size of 20 ml of milk titrated against 0.1 molar of sodium hydroxide. Looking at the step-by-step calculation for sample A, substituting its 3.4 ml titration volume into the equation yields exactly 0.15% of lactic acid. Applying the same steps for sample B with its higher titration volume of 6.2 ml, the calculation gives us a result of 0.28% of lactic acid. Here is the complete data of our volumetric analysis. Sample A, which is fresh pasteurized milk, require an average volume of 3.4 ml of sodium hydroxide, resulting in a standard acidity of 0.15%. On the other hand, sample B, which is exposed raw milk, required 6.2 ml of the sodium hydroxide, bringing its calculated acidity to 0.28%. This high acidity clarifies its commercial freshness status as sour or rejected. To clearly visualize these findings, this comparison chart contrasts both samples against the maximum commercial acceptance limit. Normal pasteurized milk should strictly fall within the range of 0.12% to 0.16% of lactic acid, While sample A sits perfectly within this safe zone, sample B significantly exceeds the threshold at 0.28%. This visual evidence confirms that prolonged exposure leads to heavy bacterial activity, converting lactose into a lactic acid and causing the milk to spoil.
In conclusion, our project successfully demonstrates the practical application of basic analytical chemistry in daily life and the food industry. Through volumetric analysis, specifically acid-base titration, we have proven that this method is highly reliable, rapid, and precise for quality control in verifying milk freshness. Our results successfully distinguish between fresh milk 0.15% of lactic acid and spoiled meat at 0.28% lactic acid.
Thank you for watching.